Today we're going to learn vocabulary terms about matter in the periodic table by using a strategy called polar opposites. The first thing you're going to do is read the passage that I'm going to hand out to you by yourself, and then once you've completed the reading, you are to complete the polar opposites worksheet. And the way that you do this is you have to read each incomplete statement, and on this, let's see if it'll focus. So for number one, we have two words right here, and there are 3 lines, and you are to put a check mark next to the word that you think is the answer to number one. The middle blank is there for you, just in case you don't know the answer to that question. But if you have chosen an answer, you are to write down evidence from the text as to why you chose that answer. So I'm going to go ahead and model the strategy by reading the passage. Matter in the periodic table. Matter is anything that has mass and takes up space. Atoms are made up of small parts of matter, and they are the basic unit of chemical elements. Everything is made up of atoms. Atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. Protons and neutrons are located in the nucleus, while electrons are located in the electron cloud. Protons are positively charged, neutrons are neutrally charged, and electrons are negatively charged. Different types of atoms make up different types of elements. For example, the element carbon on the periodic table contains 6 protons, 6 neutrons, and 6 electrons. The periodic table is a chart that contains all of the elements. Each element on the table is arranged in a specific location because of its atomic structure. We have periods and groups. Rows on the table are called periods. There are 7 periods, and all of the elements in a period have the same number of atomic orbitals. For example, period 2 has 2 orbitals for their electrons. Columns on the table are called groups. There are 18 groups on the periodic table. Groups have the same number of outer electrons or valence electrons. For example, all of the elements in group 2 have 2 valence electrons. The valence electrons determine the element's chemical properties. Chemical properties are observed by changing the makeup of a substance. One important example of a chemical property is reactivity. Chemical properties are the opposite of physical properties, which is something that can be observed without changing the chemical makeup of a substance. So that is the end of that passage, and so once you have completed that, you're to read the statements like I said. So you're going to read number one, and number one says a subatomic particle that is positively charged is a blank. So if we go back to the text, we see the sentence that says protons are positively charged. So we know that the answer to number 1 is protons. So we are to put a check mark next to the word protons, and we are going to write that protons are positively charged next to the evidence, because that is what defends our answer choice from the text. And then you are going to do the same for the rest of the worksheet.